from my side. My name is Pablo Steinberg, and I'm happy to present in the next half an hour the main findings and conclusions from feeding trials. It will be a synthesis about a number of feeding trials that Jochen Schiemer presented in his introductory remarks. And I only would like to remember with this small slide that a key objective of GRACE was to test the genetically modified maize MON 810 varieties in subchronic and chronic animal feeding trials and alternative in vitro methods in order to determine how suitable the above-mentioned test systems are and whether they provide useful scientific information for the health risk assessment of GS food and feed. And I will concentrate on these keywords, subchronic and chronic animal feeding trials. And this is a chart in which you can see the number of feeding trials which we have performed. To make it very short, we have performed 4 90-day feeding trials, and we have a 5th data set on the 90-day point in time from the 1-year chronic study with MON 810, so that we have a great database there alone from this project. And as you can see, we have not only performed 90-day feeding trials, there are 90-day feeding trials in which we have been looking at metabolomic endpoints and also at immunologic endpoints. So I will start with the 90-day feeding trials A and B with a genetically modified maize MON 810. All these data have been published already, and to make a very long story short, what we have done is to base our study design on the OECD test guideline 408 for testing of chemicals. The basic question was, since we had protocols to perform feeding trials to test potential toxicity of chemicals, the main question was if we could adapt these protocols, including recommendations from the European Food Safety Authority, to determine the safety of whole food and feed. The selected MON 810 varieties were the 2 most widely used by local farmers in northeast Spain, in Catalonia, and in each feeding trial, the corresponding near-isogenic non-GM maize variety was included. And we also included 2 additional conventional maize varieties, since at the Slovak Medical University, where the feeding trials were performed, there were no data on feeding trials with rats with genetically modified maize, so that we used this opportunity, this unique opportunity, to collect so-called historical data at the testing facility. And here, very simply, to show you the identity of the maize varieties which we used in the so-called feeding trial A, we had used a transgenic maize variety from Monsanto, and then in the so-called feeding trial B, we included the same, a maize variety, with the same event, with a MON 810 event, in this case from Pioneer hybrid produced. And we followed the following steps. These are taken from the corresponding OECD test guideline. On the one side, a very exhaustive analysis of the composition of the feed was performed. The body weight and the feed consumption were monitored on a weekly basis. Clinical and ophthalmological observations were recorded. Hematology and clinical biochemistry parameters were quantified, and a gross necropsy followed by an histopathological analysis were performed. And when doing the gross necropsy, the absolute organ weights were determined and then used to calculate the relative organ weights. And this is to show you the study design of the 2 90-day feeding trials A and B. What you can see, we use in the control group, as the OECD and the EFSA recommendation, the OECD test guideline and the EFSA recommendations say, use the highest dose which you will use of the genetically modified plant inclusion in your diet. Then we took the 33% here. Then we tested 2 dose levels of MON 810, 11 and 33%, and we went for 2 further conventional plants, which we included here at the 33% inclusion rate. We had in total 160 animals here divided in males and females. And what I've done, we have a huge amount of data there, and I'm only going to summarize this very quickly. What you're seeing here comparatively are the relative organ weights, in this case of male animals. And what you can see here, if you see a dark bar here, that is a statistically significant increase when compared to the non-GM near isogenic control group. The red one means that there is a statistically significant decrease when compared to the corresponding group. And what you can see here, that there are sometimes certain statistically significant differences. We have made a very, very strong discussion on each of these points. We came to the conclusion in the end that for the relative organ weights, but also here you will see it for the studies A and B, which I accept, there are a number of statistically significant differences. We came to the conclusion when looking at the whole bunch of data, not only including organ weights, but also the biochemistry, the necropsy data, and the histopathology data, that these differences were not event-related. You're seeing here the data for the female animals, and to make a long story short, you see here that with a relative organ weights there were almost no differences in the female animals between studies A and B, independently of the inclusion rate in the feeding trials. And you see here that there are certain differences, statistically significant differences when compared to the corresponding control groups. But again, also in the case of the female rats, when we took all the data together and we made the toxicological assessment, we came to the conclusion that these differences were not event-related. I will come back to this afterwards, because we have done not only 2, but in the end we have 5 complete data sets on 90-day feeding trials. And this is copy and paste of a table that has been, or 2 tables that have been published already on the histological findings in the study A and B. We can see here a certain amount of different findings, which all were, if you want, perhaps inflammation related in most cases. In the case of the ovaries, you see cystic follicles appearing here and there, but nothing that would show that there was any form of preneoplasia at that early stage of the feeding trials. And then I'll go over to the 1-year feeding trial with a genetically modified maize MON 810. In this case, we followed a different OECD test guideline. There is a published OECD test guideline 542 for the testing of chemicals, in this case chronic toxicity studies. And then we made use of this OECD test guideline, took into account recommendations and statements made by EFSA, in order to see that we applied this test guideline now to whole feed and food testing. In this case, we took one MON 810 variety, which was produced by local farmers, again in Catalonia in Spain. And we included in this 1-year study one conventional maize variety. We couldn't take a second one because of financial and animal housing facility constraints. But at least one further conventional maize variety was included in order, again, to collect so-called historical data at this animal testing facility in Bratislava in the Slovak Medical University. In this case, you can see here which varieties we use. The transgenic maize variety, including the event MON 810, came from Monsanto. The others are the conventional maize variety from a producer in Spain. And then we had the near-isogenic maize variety, again from Monsanto. And this is basically copy and paste from a slide I showed you before, but this is what the OECD test guideline lists as tests that have to be performed when you want to look at the safety of a certain chemical. We applied this, in this case, to the analysis of the feeding trials with whole feed and food. The complete list was performed. And what you can see here is the study design. Again, the non-genetically modified near isogenic group received the highest inclusion rate, which we then tested. Here for MON 810, it was 11 and 33%. And for the conventional one, the SY Nepal variety, we again used the 33% inclusion rate. What you can see here is for a one-year study, nothing that is very astonishing. We used 20 animals per experimental group, and that makes in the end 160 animals, 80 males and 80 females. What we did, I left that out in the 90-day feeding trials. I said we have made a very, very exhaustive compositional analysis of the maize and the feeds that were given to the rats in the end. And what you can see here, for example, is the percentage of the event in the diet, in the end diet, and you see that the numbers are quite near that, what you would say is ideal, 10.4% in the 11% GMO diet and about 31% in the 33% diet. And we have also made a quantification of a Cry1AB protein expressed here in nanograms per milligram protein. 1 year is a very long time for the feeding trials, so we had to perform produce two batches of diets. And what you can't see here, but I can tell you that will be included in the manuscript that we are planning to publish in the coming months, is we have performed a very thorough compositional analysis of the maize and the diets used for the preparation, the production of the two diet batches. What you see here is something that happens in the life of a toxicologist, and that is when you perform the analysis, then it happens here and there that you have a contamination of the maize. And what you can see here in this case is the analysis of the different diets for mycotoxin group. Those are the formunisins. And this is something which we identified at a certain time point in the project, at a time point where we had to decide, do we leave the hands off and kill this 160 animals and leave the project die off at that time point, or we continue? And we performed the analysis, and then we looked at the concentration of the fumonisins in the near isogenic control diet, and we decided to go on further. You will see that that was, in the end, the right decision. And that is shown in this slide here, because you may say, well, it's very nice to hear that you have a contamination. Now explain me, please, why you went further with it, or what came out. Does the fumonisin contamination have anything to do with the outcome of the feeding trial? We've performed a number of studies in order to decide whether the fumonisins had any influence on the final outcome of the feeding trials. And what you're seeing here is this red bar is the limit, the highest concentration of the fumonisins which you can give to a rat without seeing any toxicity. And what you're seeing here are the data for the dose the animals really received during the first 14 weeks. We have looked at this for a much larger point until the end of the study, but these are the first important 3 months. And what you can see that only in the first week, in the case of the male animals, they were receiving a dose of fumonisin which was the no observed adverse effect level. That is, we wouldn't expect any toxicity, and with time the dose was below this chronic no observed adverse effect level. This is one argument. We had then looked into the scientific literature, what do fumonisins to rats? And it is well known that if you have a high level of fumonisins in the diet, you will have problems with the kidneys, nephrotoxicity will be seen, hepatotoxicity, liver toxicity is expected. And we made a number of biochemical analyses, as I already showed you, for the 90-day feeding trials, and the functional renal and hepatic parameters measured in the blood of the rats fed the control diet for 1 year did not reveal any signs of nephrotoxicity or hepatotoxicity. We will publish all the quantitative data. This is only a synthesis because of the short time I have. And then the histopathological analysis also revealed that there were no preneoplastic and or neoplastic renal lesions here in this case, so that we could say we were not seeing anything like a fumonisin-related toxicity in these animals. The conclusion, after looking at all these results, was the fumonisin contamination of the diets did not affect the outcome of the one-year feeding trial. We have done much more than that. This is only to show you only a few data that confirm this assumption. What we did see in the one-year study is what is shown here. This is the body weight development. And what you can see here, these are male animals. In the case of the 11% GMO, you are seeing a very normal, if you want, body weight increase. The 33% are also having a certain body weight increase, but there is a small difference there, which could be 5 to 8%, perhaps to 10%, that is not statistically significantly different. And there was a question at the last stakeholder meeting how it was seen also with the female animals. In this case, you see that also with the female animals, in this case, the 11 and the 33% don't show any difference. They are somewhat lighter than the controls. And we looked then at the database we had, because naturally, when you look at a thing like that, then the first question that arises, and that arose at the last stakeholder meeting in Vienna, was, have you seen something like that before? Yes, we have seen it within the frame of GRACE. This is data which we gathered from GRACE. C is the study C, the one-year study, where you're seeing after 90 days, for example, that you have an about 5% difference between the GMO, 33% GMO-fed animals and the control animals. And what you're seeing here is basically in the study A, what we have been seeing also here is this number here, which is about 4 to 5%. And what you're seeing there is the difference in the body weight gain of animals fed a conventional maize variety within the study A. So this is something not very new to us, but the most important thing for a toxicologist is when you see something like a body weight gain difference is, how do you explain it? We made a very big effort in seeing if the hardness of the texture of the feed pellets were the difference. We had some positive results at the beginning, but I must say in a second analysis, we were convinced that that doesn't explain the differences. What you see here are the male rat feed consumption curves, and you see that the male rats are taking up somewhat less feed per week. And for the female animals, here you can see the differences are much smaller, but you can also see that somehow they are taking up less feed, which we cannot explain, at least at the moment, what is happening there. But we know very well what is going on in the animals. And what you can see here are the clinical biochemistry parameters of male and female rats in the one-year feeding trial, and what you see is that nothing happens, or almost nothing happens. You can see a very homogeneous picture, including if you compare 11 and 33% with the controls, you see almost no differences, and that applies also to the female animals. So we weren't seeing there any sort of biochemical finding at that time. And then we went into the histopathology. I must say that from the 160 animals which we analyzed, we lost 3. We didn't lose them during the feeding trial. These animals had to be sacrificed before the end of the feeding trial according to international regulations. One animal, a male rat fed the 33% GMO diet, had, I make it very easy for you, a paralysis of the hind limbs. And it couldn't then eat and drink as it should. It lost a lot of weight, and it was decided at week 33 to kill this animal prematurely. One female rat had the 11% GMO diet, was sacrificed at week 37 with a yolk sac carcinoma localized in the right ovary. And then we had a third animal that had a mammary gland carcinoma, and that was a female rat fed the control diet. And all these 3 animals were sacrificed, as I said just now, prematurely. But then we went into these very boring tables, and this is what you can see overall. You see only in a few animals, males in this case or females in this case, you're seeing almost no differences. The only thing what you see is something which you see throughout the groups, and is not strange, are cysts in the ovaries of the female animals. For the publication, we convened with the stakeholders. There was one or the other comment made, and we will do that in order to simplify for the reader the conclusions which we will take of all these data, we will present it organ per organ, what is going on. So that is in the end much easier for the reader to follow. But the main thing when you're doing a 1-year feeding trial is to look what happens with benign and malignant tumors. Are they there? Which are the tumors? Which are the lesions? What you can see here, I have subdivided the data in so-called benign tumors and malignant tumors. I go this slowly through it. You have one lipoma, and you see here occasionally one or the other lipoma in male as well as in female rats. We found a cutaneous papilloma in a female rat in the control and also in the 11% GMO. And as I said before, with the one animal that had to be sacrificed prematurely, we then had 2 animals that had received the conventional diet. What you can see here is this is a cyst adenoma. This is a benign tumor. Then under the malignant tumors, we had a very, very limited number of tumors. You see the mammary gland comedocarcinoma in a female rat in a control animal. We have seen a yolk sac carcinoma in a female rat in the 11% group, GMO group, and then we have seen a so-called pituitary in the apophysis detected hemangioma in a female rat having received the conventional variety. What you see here is that practically in the 11% group, you're seeing single findings. In the 33% group, only a lipoma, and you're seeing that these incidences are also found if you feed the animals with a control non-GM, including diet, or even with a conventional diet. And that's why if you take together biochemistry, hematology, clinical science, the necropsy and the histopathology findings, even if we have seen this body weight decrease, we don't think that that is of a toxicological relevance. And in the end, I think I'm quite well in the time. I still have 1 or the other minute. We've spent quite a lot of energy in looking at immunological parameters. During the stakeholder meetings, again and again, the question came up if besides the classical endpoints which I have been describing here and listing here, if there was something happening with the immune system. And we have looked at a huge amount of parameters. I shouldn't say I, but we within the GRACE Consortium have done that. That is work performed on the one side by the group of Karina Del Patient at INRA in France, and also by Jana Tulinska and her collaborators at the Slovak Medical University. And what I've done here in this also very boring slide is to put together the few findings that the ladies have found. And what you can see here, there are individual signs that something is going up or down in comparison with the non-GM group. But basically the message to take home, if you look at all these, this is only a small synthesis of what has been found. What you're not seeing is a table which is 4 times larger with immunological parameters describing the cellular immune response, where you see no differences between the groups. And if you look at the humoral immune response, this is the question of allergenicity. that could arise by Cry1AB, you basically see that nothing specific really happens. The specific anti-Cry1AB IgGs or IgEs, for example, have not moved between the groups. They are absolutely the same. In this case, you see a specific anti-MACE IgG level increase at the 11% GMO in, I forgot to say, in the so-called study D, in the longitudinal study, but you don't see anything like that in the study E. So that taken together, we can say that neither the humoral nor the cellular immune response are affected by feeding the animals for 90 days with MON810 containing feeding diet. So, and there I come to the last few slides, and these are the conclusion slides. As I told you, we have made a huge amount of feeding trials. Here you have put together the A and B. These are 90-day feeding trials. Only to remember, what we name the study C is the one-year feeding trial, and in the end, the two further 90-day feeding trials where we did the longitudinal studies and where the immunological data set came from. And you can see here the summary for male rats and relative organ weights moving around. And basically, you can see that we have, over these different feeding trials, haven't found a pattern that would say you have something that is bothering there, at least the relative organ weights. And I would like to recall that we had already I would say, very controversial discussion with stakeholders about the relevance of such differences. And our assessment at that time point when we published the data was that even if we were seeing certain differences in relative organ weights, these were not of a toxicological relevance and could not be declared as event-related. And you can see in the one-year study that this has basically been corroborated. And then we went on, this is the data, the summary table for the female rats and relative organ weights, and you see almost that in all cases, not in all cases, but only in very individual cases, we are seeing something like a statistically significant difference, but there is no pattern there, which could be event-related. Then we had the clinical biochemistry parameters, and you can see this. We have discussed it many times, and that you had in the first two 90-day feeding trials, you had a pattern that was bothering. We don't need to discuss that away because we have presented the data publicly, but in the study C, in the one-year study, you can see that what many of us, or many of you have criticized, could not be corroborated. Many of you had said, well, you're seeing this is a problem there. And I agree as a biochemist that, well, or as a toxicologist, that if you look at this, you have to be very careful with your assessment. But if I look at the one-year study, I must say in the end, after all the criticisms, that we were right with what we had deduced at that time. And what you see down here is that the study D and study E data which you have here shows these are complete 90-day feeding trials, and they corroborate what we had already seen in the earlier studies regarding the conclusions, if the differences seen in A and B were relevant or not. Now we had the same thing for the clinical biochemistry parameters, and you see individual bars which shows you that there is a statistically significant difference, but again, and I'm not showing numbers, I had them at the beginning, and Jochen and his team found them extremely boring, so I left them out and showed them in form of bars. You see here no real spectrum of differences which are continuous and which you could say something about an event-related effect. One thing which, because of the short time I have, I'm almost finished, you don't see any dose-dependent effect. You don't see something which is reproduced among males, among females, or when you compare the genders. So, to put the things together, the results obtained in the 4 90-day feeding trials as well as in the 90-day point in time of the one-year study performed in the frame of grace show that the MON810 maize at a level of up to 33% in the diet did not induce adverse effects in male and female Wistar rats after subchronic exposure, independently of the different genetic backgrounds of the event. In the case of the 90-day feeding trials A and B, it is obvious that statistically significant difference regarding a number of parameters between the control groups and the groups being fed the GMO diets for 90 days were observed, but the differences were interpreted as being unrelated to the MON 810 event. Regarding the one-year feeding trial, one can say the results obtained in the one-year study performed in the frame of grace show that the MON 810 maize at a level up to 33% in the diet did not induce adverse effects in male and female Wistar Han RCC rats after chronic exposure. The statistically not significant decrease in body weight in parallel with a lower feed consumption observed in rats fed the MON 810 maize for 1 year in the absence of any correlating variation in the different measured OECD endpoints was interpreted as being not toxicologically relevant. And regarding the effects of the maize on the immune system, the results obtained in the 90-day feeding trials D and E performed in the frame of grace show that the MON 810 maize at a level up to 33% in the diet did not affect the humoral and the cellular immune response in Wistar Han RCC rats after subchronic exposure. A very limited number of parameters were increased or decreased in the GMO-fed groups when compared to the control groups, but these changes were not consistent between the studies D and E and were independent of the MON 810 level in the diets. And last but not least, no signs of allergenicity were observed in Wistar Han RCC rats fed the MON 810 maize at a level up to 33% in the diet for 90 days. Thank you very much for your attention.